Fundamental counting principle. Suppose A and B are two events. The first event A can occur in P different ways. After A has occurred, B can occur in Q different ways. Then the number of ways that two events A and B can occur together is the product PQ. Let's illustrate the fundamental counting principle with help of few examples. The first example is a menu has 6 different sandwiches with 3 choices of potatoes, 3 different types of salads, and 5 different types of beverages. How many different lunches can be ordered consisting of sandwich, potato, salad, and beverages? So let's find out the total number of lunches that can be ordered. Let's start with different types of sandwiches. So the number of sandwiches that can be ordered are 6. So let's write that down. And with each sandwich, there are 3 different choices for potato. So let's write down potato as well. Potato. And their number of choices are 3 here. Let's write down 3. And after potato has been selected, there are 3 different types of salads. So salads are 3, and there are 5 different types of beverages. So let's write that down. Beverages, and these are 5 different types. According to fundamental counting principle, the total number of possible combinations would be the product of all these numbers, 6 times 3 times 3 times 5. So the total number of lunches, total possible lunches that can be ordered are equal to 6 times 3 times 3 times 5. Let's take the product, and this product would be equal to 6 times 3, that would be 18, times 3 times 5 would be 15, and if we multiply 18 with 15, we get 270. So there are 270 different types of lunches that can be ordered with 6 choices of sandwiches, 3 choices of potatoes, 3 choices of salads, and 5 different choices of beverages. Let's do the next question. In next question, we are required to find the number of Canadian postal codes that can be made from 6 characters. So the question is, Canadian postal codes consists of 6 characters. Each character can be any letter from A to Z or any numeral from 0 to 9. How many postal codes are possible in this situation if letter, number, letter, space, number, letter, number is the format of the postal code? So here, if $sign represents the letter, so let's write down example number 2. Example number 2. Format of the postal code. Format of Canadian postal code. Postal code is, it's like letter. Let's write L for letter and N for a number. N, L for letter, and usually there is given space, and then number, letter, and then number. Example would be R0, B1, N8. That is just an example. So how many different choices for the first letter? So total number of choices. So total number of postal codes, postal codes which are possible. There are 26 different choices for filling out the first letter, because letter could be anything from A to Z. And then for number, it could be any number from 0 to 9. So the choices here are 10 from 0 to 9. Again, because there is a letter, if you look at this, first is letter, so there are 26 choices. There are 10 choices for the number, and again there are 26 choices for the letter. So let's write that down. So this will be 26 again. And now 1 is again a number, therefore there are 10 different choices. And for n is a letter again, there are 26 choices again. And the last one is a number, therefore there are 10 choices. So this is number, letter, number. Every time there is a number, there are 10 choices, and every time there is a letter, there are 26 choices, because there are 26 letters and there are 10 numbers to choose from. So if we multiply, this would become 26 times 10 would be 260 times 26 times this would be 2600. And if we multiply each one of them, this would give us 60 times 2600. 2600, and upon multiplication, how many possible postal codes are? There are 17,576,000 Canadian postal codes if we follow this number. Now for each province, let's say that we fix the first letter. For example, if we fix, if all postal codes for Manitoba start with letter R, then how many postal codes will be for Manitoba? Then postal codes for Manitoba, because we are fixing the first letter in this format, so there is only one choice for the first letter, and as usual there are 10 choices for the number and 26 choices for the third letter, and as usual there are N, L, N. So this would be 10 times 26 times 10, and because there was only R that was fixed, so there were N and then L. Therefore, the total number of choices for Manitoba postal codes would be 260 times 2600, and this should give us the answer 676,000. So that many postal codes can be made for each province if the first letter of the postal code is to be reserved for each province. Let's do next question. And for next question we are given that draw a tree diagram of all possible outcomes that are when a coin is flipped in the air and dice is rolled at the same time. Let's A is the event that denotes outcome of the coin or the flip of coin. If let's write it example number 3. If A denotes the outcome for flip of coin, then in how many different ways A can occur? There are 2 ways. Then A can occur in 2 different ways because a coin has only 2 possible outcomes. Either it could be head or it could be tail. Similarly, if B denotes the throw of dice, because dice has 6 faces. If B denotes the throw of dice, then B can occur in 6 different ways. This is, and according to the fundamental principle, total number of ways according to fundamental principle of counting, fundamental principle of counting. How many ways these 2 events can occur? According to fundamental principle of counting, 2 times 6 is equal to 12. Equal to 12 is the number of ways A and B can occur. A and B can occur. But there could be different presentations. This is simply if we want to calculate the total number of ways in which A and B can occur, but the question requires us to make a tree diagram. If that is the requirement, then let's start from here, and for tree diagram we are going to draw branches, 2 branches, so that each branch denotes the outcome of the first event. So because there are only 2 outcomes for the first event, therefore we are only drawing 2 branches. And for each of the branch, so this is head, let's say, and this is tail. If that is the case, for each possible outcome of the coin, there are 6 possible outcomes for the dice. Therefore, we are going to have 1, 2, 3, 4, 5, and 6. So there will be 6 different choices or 6 different branches, I should say, for. So this branch should be to 5 and this will be to 6. And similarly, if the outcome for the coin was tail, then there should be again 6 different branches. 1, 2, 3, 4, 5, and 6. So 1, 2, 3, 4, 5, and 6. This is called a tree diagram. So if we were to list the outcomes would be H1, H2, H3, H4, H5, H6, and if the outcome for throw of coin was tail, then this would be T1, T2, T3, T4, T5, and T6. The set of all these possible outcomes will be called a sample space that we are going to study later when we start probability. But this is what is called the tree diagram for flip of a coin and throw of a dice. So this is the starting point.